All right, pick up your colored pens. Let us see how we're doing with the concept from last time we had a formal lesson. So let's see what we got. Number one, we'll start with Ethan and then India.
Negative 3,600.
Okay?
Negative 3,600.
So you two agree. That's good because the answer is negative 3,600. If you got it correct, mark it correct. If you got it wrong, mark it wrong and write down the correct answer using your colored pen. Number two, what did we get? We'll start with Aaron and then Yasmin.
1,500. Negative 1,500.
So we have a disagreement. What do you think, China?
1,500.
It comes out to positive 1,500. So Yasmin, that tells me that you knew what to do. You just made a mistake with the positives and negatives, and we can talk about that. Number three, up the level of complexity a little bit. We'll start with Christopher and then Christian.
290.
Okay.
290.
You both got 290? Wow, very good. 290 is correct. 4, 5, and 6 was a bit different. You are not evaluating the expression with values. You're simplifying the expression. It's a little bit harder. So we'll start with China and then Brianna.
Negative 56 times Z. 56 times Z.
So you guys disagree. What do you think? Yasmin?
56 times Z.
It is negative 56 times Z. So now we're getting to the point where I can tell that students are getting confused by the rules for integers. So we'll review that for a moment in a little while. Number 5 looks really messy, like unbelievably complicated. So we'll start with Chris this time and then go back to Aaron. And my quiet students, stay on your toes because I'm going to call on you anyway. Go ahead, Chris.
Negative 29 plus Y.
Okay.
1,000 Y.
Big disagreement.
100 Y.
100y. What do you think, Deandra?
100.
It is 100y. Number 6. This question actually looks a little familiar. Alex and then Amaya.
500 plus N plus 500.
So you said it differently, but it's basically the same thing. 500 plus n or n plus 500 is correct. Very good. We were also last time introduced to unit analysis, a very important skill for you from now until you get all the way through college and beyond. So let's see how we're doing with it. Number 7, what did we get? We'll start with Nicole and then Ethan.
I got 3.5 times Z.
Okay, what'd you get, Ethan?
7,000.
Okay, very different answers. Brianna?
7,000.
It comes out to 7,000 pounds. I can tell Nicole, and I put you on the spot, and I apologize for that, but I can tell you misunderstood the question. I was asking you to convert. I wasn't asking you to rewrite it in a different way. I was asking you to convert. We're going to go over number 8 when we're done, so hopefully you'll be able to learn a little bit. Number 8, let's see if anyone is able to do this complex question. Aaron and then China.
900.
What'd you get?
15 hours.
Okay, big disagreement, Deandra.
900 hours.
It comes out to 15 hours. If you got 900, that means you did part of the question, but you misunderstood what we were looking for. And what about 4.56 meters to centimeters? Brianna and then Chris.
156 centimeters. 4,560
So we disagree. Very good. Close, but a bit of a difference. What do you think, Benjamin?
I didn't get that.
Okay. Well, it was a lot of questions, but none of them were really optional. Christian?
456.
Yeah, this one comes out to 456 centimeters. And that actually illustrates the power of the metric system. mean, the metric system as far as measurement and converting things is so much easier than our system. It's amazing that we haven't converted over all these years. Because look, 4.56, 456. It's the same numbers. All you have to do is move the decimal place. There are 100 centimeters in 1 meter. So you move the decimal place twice. All right. So let's go over a few of these. First of all, let's get a grade first. So there were 9 questions. Make a fraction out of 9. 6 out of 9 would be a 67%. That's not great, but at least you definitely seem to know what you're doing. If you got better than that, that would be really good. 7 out of 9, 8 out of 9, 9 out of 9 is probably pretty hard to do, but... So, I had put this little note here that says no calculator for numbers 1 through 6, and I want to illustrate the reason why. The last lesson, the whole point was you learned 2 properties, and you were asked to start using them to help yourself see math a little bit differently. So I want to take number 2. So everyone look at their number 2. Give me a thumbs up if you got number 2 correct. 1, 2, 3. We still don't know the thumbs up system after 6 weeks? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Put your thumbs down. So 2/3 of my class got it. So let's see what they did. We've got negative 4pn. What operation is being done in here with something written like that, Taylor? Yeah, it's all multiplication. So we really have negative 4 times p. But p is negative 15. So write it like that. If you didn't write it like that, you made a mistake. Negative numbers, if they're next to an operation symbol, should have parentheses around them. And then it says times n. N is 25. Now I said you may not use a calculator, and so you had to actually think about what to do. If you didn't think about what to do, and you just started left to right, if you just did this, that's not horrible, but that leaves you with a difficult multiplication problem. What change could you make to make this work out much easier for you? Taylor? Okay, well, I don't see a 4. Okay, so that's a big difference, but yes, you're right. If we do this times this, now, could someone explain why I'm allowed to do that? I'm going to give you a hint. I'm going to go like that. What lets me do that? India? Wow, you said that beautifully. We commute the number, commutative. So then we can do the negative 4 times the 25. Well, let's forget about the negative for a second. So we just do 4 times 25. What do we get? Someone raise their hand. 4 times 25. Oh, a lot of people can do that. Am I?
Negative 100.
Okay, well, 4 times 25 is 100. And it's negative 100 because the signs are different. The answer is negative. So Yasmin and Brianna and a few other people had gotten a few questions wrong because somehow we were confusing the signs. This is negative, this is positive. The signs are different. That means the answer is going to be negative. We get negative 100. Now we put the negative 15. The signs are the same. Someone finish the statement. The signs are the same. Only 3 people can finish the statement? Oh, a whole bunch of people. DeAndre? You said that perfectly. The answer will be positive. So we know it's going to be positive something. The question is, how do I multiply 100 times 15? Aaron?
You need the zeros and then 15 times 1 and then add 0.
Yeah, you just take the zeros and basically tack them on to the end of this number. That's why multiplying by 10, 100, 1,000 is so easy. All you have to do is take the zeros and move them over. So this becomes positive 1,500, and that's why we got that answer right there. Okay? Comments, questions on that one? Comments or questions? Okay. So now I want to focus on number 8. So everyone look at their number 8. Give me a thumbs up if you got number 8 correct. There's a few people who did it. It was hard. It was really hard. Put your thumbs down. So now everyone's got their colored pen ready. We're going to work together. Unit analysis. This is a perfect example of why unit analysis is a powerful tool. So we're going to set up a fraction bar equals, and I didn't leave myself a lot of space, but we're going to start with the number that we're trying to convert, 54,000 seconds. And then at the end, we're going to put the unit of measurement that we want to end up with. We want hours. So I need to get from seconds to hours. So I have some people who still have the textbook open. Would you look at the back and find me the conversion factor that goes from seconds to hours? The conversion factor that goes from seconds to hours. From seconds to hours. China?
It goes to hours and minutes.
Okay, but I don't want that one. I want the one that goes from seconds to hours. Good, that was beautifully said. There is none. And this is why unit analysis is so important. So China, which one did you find?
1 hour equals 60 minutes.
Okay, but what I have seconds here. Is there one that has seconds in it?
1 minute equals 60 seconds.
Good. No, that's good. 1 minute equals 60 seconds. So we have this conversion factor. So that's all we have so far. I want hours, but I don't have something that goes from seconds to hours. So let's start with this. So we're going to use this conversion factor, and I need to put it here. But you have to put the numbers in the right place. So it's either going to go 1 minute, 60 seconds, or it's going to go 60 seconds, 1 minute. Which way must it go? I know they know over here because they got it right, but now hopefully you're catching on. Yasmin? So where does the 60 go? On the bottom. So why? Why does the 60 seconds have to go on the bottom? It's not a choice. It has to. It has to. Ethan?
Because you're going to be dividing the 556 seconds from 60.
Well, we are going to divide, but I didn't know I was going to divide. What's the real You're right, we are going to end up dividing, but what's the real reason why we have to have the 60 seconds on the bottom? China?
Because the seconds have to go away.
I love the way you said that. The seconds have to go away. And the only way to make them go away is one has to be on top and one has to be on the bottom, and then we can cancel them out. This can now cancel that. If I put the 60 on top, I can't cancel them. This is how it has to be. So now we could do this, but then we're going to end up with minutes. I don't want minutes. I want hours. So now I have to get from minutes to hours, and China did tell us already, but I would like someone else to tell me, what was the conversion that goes from minutes to hours? Alex?
1 hour equals 60 minutes.
Okay. So we've got the conversion factor 1 hour equals 60 minutes. Once again, we're going to use this, but which way does it have to go? There's one way it can go. You got a 50-50 shot, so if I call on you because you're a quiet student, you could get it right even if you're not sure, but I'd like you to have a good reason. Brianna?
1 hour goes on top and 60 minutes goes on the bottom.
That was very well stated, and I love the confident tone of your voice. That was excellent. But you need to be able to explain why. Why does it have to be that way?
So they can cancel each other.
So what can cancel?
The minutes and
That's right. The minutes are going to now cancel each other out. That's what we wanted. Like China said, we want them to go away. But now look what I'm left with. Hours. That's what I wanted. So now you're left with a multiplication and a division problem. We multiply everything on top, multiply, multiply, multiply everything on the bottom, multiply, multiply, and then divide at the end. So we end up with 54,000 divided by 3,600, and you end up with 15 hours. That is why unit analysis is such an important skill, because there's going to be a lot of times you need to convert from something to something else where we don't have a simple conversion factor. Okay? Comments, questions on on number 8.
On the things like the weights, you know how you have that dot right there, on top. So that means multiplication.
Yep.
But how I got the answer, I divided.
But that's what I said, is you have to multiply everything on the top, then multiply everything on the bottom, and then divide at the end. That's what a fraction bar is. So you did it right. And that was a great explanation that you just gave. Okay? Give me a thumbs up if you are a 7, 8, or 9 with unit analysis. Be honest. If you're not, you're not. Doesn't make you a bad person. Good. Put your thumbs down. So we're going to be doing some more work with it, and you will get more and more comfortable as the year goes on. You will also see this in science class as well. You should see this with Ms. Mitchell. Okay? Comments, questions on anything? Okay? Today we're going to study a third property. It's called the distributive property. I'm going to be honest with you. We're heading into some heavy algebra stuff. So this concept, and for the next couple of weeks, some of you are going to struggle through. I'm going to be honest. There's a lot of bright young people in this room, and sometimes you guys are often you guys are used to hearing something or seeing something and instantly understanding. That's how a lot of you, not everybody, but a lot of you got through 5th grade and 6th grade that way. The teacher showed you something for the first time and you just, okay, I get it. And then you were able to do it. That's not going to be the case today at all. I'm going to show you something and your brain's going to be going, huh? What is he talking about? I do not understand. There's nothing wrong with that. It's going to happen. I'm telling you it's going to happen. How do I know? Because I'm an expert. I know middle school children, and I know middle school children and math, and I know middle school children and algebra. It's going to happen. It happens to my Algebra 1 honor students. Okay? So the point I'm going to make is don't be afraid. Just because your brain is going, I don't get it. That doesn't mean stop trying. I think a lot of young people, when they're feeling like they're not going to get it, you just stop. And you're like, well, that means I won't get it. That's not the case. Okay? Nobody sits on a bicycle the first time and can immediately ride with no training wheels and no help the first time. But if everyone stopped because they couldn't do it the first time, we would not have as many happy young people riding around on bicycles as we do because no one would ride bicycles. So I understand that algebra and math is not nearly as fun as riding a bicycle. That's not the point. The point is it's the same process. You've got to get over your mind telling you that something's not right. So let's jump in, and again, follow along with me. Eventually it will make sense. Okay, so the property we're going to study is called the distributive property. And you're going to have to know it. You're going to have to know what it's called. You're going to have to be able to pronounce that word, distributive, for the rest of the year and beyond. So, I have all of these models and examples. I am going to start with the models to explain how the distributive property works, and then we're going to use these examples to quickly just demonstrate how you're going to do it. So, let me hide the examples for a moment and just start with the models. First of all, what does the distributive property look like? It looks very particular. It will always have grouping symbols. So you will always see parentheses. Now, does that mean that every time you see parentheses, it's distributive property? No. But every time you see distributive property, there will either be parentheses or brackets. Also, you will always have a number or a letter outside the parentheses, and you will always have an addition or subtraction problem inside the parentheses. And that's what the distributive property is. It's a special case that you have to learn how it works. Okay? So we can see here in the second model the same exact thing. We have an addition problem inside parentheses and we have a number outside parentheses, and there are grouping symbols. So here's what the distributive property says to do. If there is a number outside and there's an addition or subtraction problem inside, we take the number outside and multiply it times everything inside. So you're going to be drawing these arrows over and over again today, tonight, for the next 3 months. Each arrow means multiply. Each arrow means multiply. So we multiply A times B, we get AB. We multiply A times C, we get AC. Now we're going to use numbers in a couple of minutes, and you'll see how it works with numbers. Right now I'm just modeling it, okay? Same thing will happen if the number is on the right-hand side. We draw an arrow from here to here, and we draw an arrow from here to here. That means A times B, AB, A times C, AC. And that's the distributive property. So let's go through the first step with a number of examples. Okay, let's look here. So I'm starting with 4 times the quantity 6 plus 3. Now, you were taught a month ago, approximately, that when you have parentheses and multiplication, you always do parentheses first. Today, I'm going to ask you to not do that. That's a little weird, right? For a teacher to tell you to do something one way a few weeks ago and then tell you to stop doing it. I'm just telling you to stop doing it just for today. You'll understand a little bit later. So what I want to do is use this to illustrate the distributive property. So, the 4 gets multiplied times the 6. The 4 gets multiplied times the 3. And here's how we're going to write it. And you need to get used to this because you're going to write this like this every time. 4 times 6, underneath we're going to write 4 times 6 plus, and now we're going to do 4 times 3. And write 4 times 3. Now, we can simplify that. 4 times 6 is 24, 4 times 3 is 12, and then we can add it together. I'm not going to do that right now. We're going to do that in a little while. Okay? Are there any questions so far? Okay, good. So, what if there's variables involved? This is really the algebra. So the negative 6 gets multiplied times the x, and the negative 6 gets multiplied times the 5. So we're going to write negative 6 times x plus negative 6. Now, since I'm going to write a negative number next to a plus sign, I'm going to put it in parentheses, times 5. And that is distributive property. It's also the same thing if it's going in the opposite direction. If it's going in the other direction, it's still the same thing. This one has a subtraction symbol in between. So we've got 5 times 7 and 5 times 2, but there's a subtraction sign. So it's 5 times 7 minus 5 times 2. And again, this is multiplying. Okay? Now, if you still don't understand, you have no idea what I'm talking about, as I already explained. That's expected. The idea is to follow the path that I'm going to lead you on, and eventually it will make sense. Now, I also like to teach by showing you, based on my experience, common mistakes. So I have a lot of experience with this concept in pre-algebra and algebra. And I have seen over my years teaching all the mistakes that students make, and there's a few that come up all the time. So look at the first expression I wrote on the left, 8 plus the quantity x plus 5. So here's what my students do. My students start to learn distributive property, and then they get confident. And they go, okay, Mr. Gallett, I get it. I get it. Distributive property means multiply. So I see the parentheses right here, Mr. Gallett. So this means multiply 8 times x and 8 times 5. 8 times x plus 8 times 5. Does anyone know the mistake? We got 5 confident people. DeAndre?
You're not supposed to multiply the 8 times x and 8 times 5.
Why not?
Because there's an addition sign.
That's right. That was a fantastic explanation. There's an addition sign right here, and that actually means that this is not distributive property. This is distributive property. This is distributive property. This is distributive property. This looks like it, but because there's an addition sign right here, this is not distributive property, and you cannot do this. Now, you were taught something else. You were taught something last time that you can do. It's really just 8 plus x plus 5. So you can do 8 plus 5. Right? You learned that you could commute this over to there and make it 8 plus 5. And so this is really x plus 13. So you're allowed to do that. Any questions about that common mistake? Okay, here's the second common mistake I see. My students become confident, which is what I want, but they don't see everything. They don't see all the different examples, and so they do things they're not supposed to do. So they say, Mr. Gallett, I get it. Distributive property, I see the parentheses right here, so I'm going to multiply, and I'm going to multiply. And so I'm going to get negative 7 times h minus negative 7 times 8 plus negative 7 times 5. Anyone see the mistake? Christian?
The plus 5 is not in parentheses, so you don't time it by names.
Wow, that was a phenomenal, extremely high-level explanation that he just gave. The plus 5 is not inside the parentheses, so the plus 5 is not part of the distributive property. Now, this is distributive property, but I just went too far. I don't do this, and I don't do this, and I don't do this. I do the distributive property, but then I just add 5 to it at the end. So this would be plus 5. So I do distribute here, and I get this, but then I just add 5. Okay? So these are 2 common mistakes I see. Here's the most common mistake. Let's see who can catch my mistake I make with 9 times the quantity r plus 8. All right, Mr. Gallett, I see all the mistakes. I get it now. So I'm going to do distributive property. I multiply, and I get 9r plus 8. What's the mistake? Brianna?
You're supposed to multiply 9 by each number.
Again, I must say that was a fantastic explanation. I drew arrows, but I only multiplied the first one and I didn't do the second multiplication. I see this very, very often. This is the most common mistake I see. And that is incorrect. You have to multiply both, otherwise it's completely wrong. It's not part right and part wrong. It's completely wrong. So this is wrong. It's supposed to be 9 times r plus 9 times 8. That is distributive property. Okay? Well, you guys seem to be doing extremely well so far. Are there any questions before we get into the formal examples? Good. You guys are doing well. Keep it up. So here we go. Example 1. is broken into 4 parts. Read the instructions, but you don't have to copy this. Just read it. It's important to see it because you're going to see the same thing in the textbook as well. And you got to get used to how the instructions are phrased. Evaluate the expression using the distributive property and mental math. Okay? So we're not using calculators right now. That's when I say use mental math, that's what I mean. Now, before we actually do part A, I want to emphasize something that I kind of said before. If 10 years from now, you get your first job working for a banking firm, and you're an analyst, and they give you some work that involves a lot of numbers, if they ask you to do this, you should do 9 plus 4 and then multiply times 2. 9 plus 4 is 13, times 2 is 26. So you should be able to do this instantly when you are 22, 23 years old, working in your first analyst job. Today only, I'm going to ask you to do it differently because I'm trying to illustrate something to you. Okay? So when you get your first job and you start doing this, and you start drawing arrows, and your boss asks you, why are you doing that? And you say, well, Mr. Gallard in 7th grade taught me to do this. He's going to kick you out of the office and possibly fire you and then he's going to call me and say, what are you doing to my new employees? You do not do that. I'm asking you to just do this for today, okay? So, this is an example of distributive property. I can see it because there's parentheses, there's a number next to the parentheses, and then there's an addition problem inside. So what we do is we multiply. For the first bunch, we're going to rewrite it. 2 times 9 plus 2 times 4. Now simplify. Use mental math. 2 times 9, someone raise their hand and tell me what that is. Okay, a whole lot of people know. Taylor? 18. And 2 times 4, what do we get? Alex? 8. And 18 plus 8 is 26, which is what we got doing it the other way. So you can see that the distributive property does lead you to the right answer. And today I'm just using it to illustrate this step right here. Questions? Good. Part B. And by the way, there's many of you who are going to have really important jobs when you graduate college. Some of you are thinking, well, Mr. Gall's crazy. I'm not doing that. Trust me, there's going to be a lot of you who are doing some high-level math with money and balancing budgets and stuff like that. Okay? So, part B. So again, I'm first asking myself, is this distributive property? I see parentheses. I see this, but is this distributive property? Someone give me a yes or no answer with some confidence. What do you think, Aaron?
Yes.
Yeah, it is. Even though there's this second parentheses, that's just because it's a negative number, and this is distributive property. So I'm going to draw my arrows, and I'm going to follow the rules. It's negative 4 times 4, and negative 4 times 11. Negative 4 times 4. This time there's a subtraction sign, and then negative 4 times 11. Now simplify. Well, now I'm asking you to do mental math, and you got to know the rules, and you got to know your multiplication. So, what's negative 4 times 4? Benjamin?
-16.
Very good, negative 16. What about negative 4 times 11? What do we get with that? Mental math, can you do that? Yasmin? Yeah, it is negative 44. Very good. Now what is that? That looks like a mess. I don't know how to do that. Negative 16 minus negative 44? Boy, Mr. Gallard, I hope I don't have a job where I have to do that. India? Oh, so you do know how to do it. Oh, okay. You do know how to do it. Keep, change, change. Outstanding. She was right. Now we have negative 16, positive 44. What do we end up with? Still not easy, but you can do it. I mean, what does it really mean? 44 positives and 16 negatives. It really means 44 minus 16. So what do we end up with, Amaya?
22.
Not 22. You're in the ballpark. Christopher?
28.
You got 28. Very good.
So you could, wouldn't it be easier to just get out of line to the sign?
If it's easier for you, absolutely. It's not easier for me. But if that makes sense to you, then do it. If you know add a line, change a sign, then that's the same thing. Add a line, change a sign. Good, we're doing extremely well. So now I'm going to kind of throw a wrench in the works. Now we're going to explore something that actually last time we had class, we were actually doing, but you didn't realize you were doing distributive property. Now I want to multiply 5 times 103. And you cannot use a calculator. What did we talk about doing last time we were together? How could we do 5 times 103 and do it mentally? Oh, we do have some people who know. China?
I think it was you do 5 times the 3 and you add the 100.
Close. We are going to do something like that. Can you clarify what she's saying, DeAndre?
Do 5 times 10 and 5 times 3 and add 3.
Close. It's not 5 times 10. Because even though that looks like a 10, it's not a 10. What is it really? That's right. So it's really 5 times 100 and then 5 times 3. That's how you do that. 5 times 100 and then 5 times 3. And guess what? That's actually distributive property. You didn't realize it. So let's see how that looks. So in this case, we're going to actually rewrite the question. 5 times 100 plus 3. And this is why the distributive property can be actually useful. We tend to do this mentally. 5 times 100 is 500. 5 times 3 is 15. 500 plus 15 is 515. So there is absolutely no reason why anyone in this room needs a calculator to multiply 5 times 103. And this will work with anything like this. If I asked you to do 8 times 109. 8 times 100, 8 times 9, add it together. 7 times 102. 7 times 100, 7 times 2. No calculator should be used for anything like this. Okay? Any questions about that? India? No? Okay. Part D is a little bit harder to see, but I'm actually surprised more adults don't have this skill. Because in our world, for whatever reason, when we buy things at the store, they very often are priced like $1.99. Like I still don't understand why it's just not $2. Like, does that penny really make that much of a difference? But if you go to Burger King, McDonald's, any restaurant, the prices are always $1.99, $2.99, $4.99. Sometimes they make it a little wacky and it's $4.95. But, well, if I want to treat my friends to lunch and we're all going to get the Whopper Jr. and it's $1.99 each and I got 5 friends, how much money do I need? Am I going to sit there and go $1.99 times 5? No, that's ridiculous. But what you should do is change this to, what is it really close to? It's $4. But if we do want an exact answer, how close, what did we add to this to turn it into a 4? What did we add to it, Amaya? A penny. So now we're going to subtract that penny at the end. And how do I write a penny? I write it like this. 0.01. So if I round up to 4, do that easy multiplication, and then subtract the penny at the end, but it's not just a penny. It's actually 3 pennies. So it's distribute. 3 times 4 is 12. 1 penny times 3 is 3 pennies. So how much money do I need to treat my friends to this $3.99 item? How much money, exact money, do I need? Chris?
$11.97.
Exactly. $12 minus 3 cents is $11.97. Yes, you're right. There's tax. Okay, any questions on how we did that? You guys are doing extremely well. Keep up the good work. Let's see how you do on your own. Checkpoint number 1, A and B, you may not use a calculator and you must use the distributive property. You may not use the calculator and you must use distributive property. You got 2 minutes for 2 questions. Might have to think about it for a minute, and there's more than one way to do it. All right, pick up your colored pens. Let's see how you did on your own. And again, I want to say before we begin grading, if you don't get it yet, it's okay. Doesn't mean there's something wrong with you. It just means you didn't quite get there yet. So mark it correct or incorrect, write down the correct answer, and see if we can figure out where we went wrong. But let's get the answers first. Part A, what is the correct answer? You got 1, 2, 3, 4 people all clustered around the same part of the room. Maybe there's some special energy at that part of the room that makes them all get the answer. What do you think, Brianna?
15.20.
Okay, what'd you get, Christian?
16.
Okay, so we have a disagreement. What do you think, Dalia?
16.98.
Okay, so we got a massive disagreement. Correct answer is 15.2. And this is how I did it. It doesn't mean it's the only way to do it, but that's how I did it. Because that you can do mental math with. What about part B? What'd you get? We'll start with Kiara and then Benjamin.
It was hard for me to
Okay. Good. That's a good explanation. Benjamin? 27. Okay. What do you think, India?
27.
Correct answer is 27, and that is how we get. So let's talk about part B first, because it was a little bit easier. It was distributive property, so all you had to do was multiply the 3 times the 12, and that's where you get 36. The 3 times the 3, you get 9, and then you subtract them. 36 minus 9 is 27. The harder part in part A was understanding that 3.8 is really close to 4. Now, Dalia did it correctly. The only mistake Dalia made was she put her number in the wrong place.
Put an extra 0.
Yeah, you just put an extra 0. That was no. So that's a little mistake, and she'll know next time. 3.8, think of that as $3.80. And how do we write 20 cents? We write 0.2. She accidentally put 0.02. That's 2 cents, not 20 cents. Okay? So that was incorrect, but she had the right idea. And then we multiply. 4 times 4 is 16. 4 times 0.2 is 0.8. And then you subtract them and you get 15.2. Okay? Good. Ethan?
Number for letter, I got it wrong because I thought of it as money and I put 15.92.
Okay. Which was similar to what Dalia had done. Okay, but you can think of it as money. But the problem is that your brain is used to seeing money written like this. That's, how many cents is that?
80.
And if it's just 0.8, is that 8 cents? No, it's 80. There's a ghost 0 right there. So you have to train your brain to put that 0 in automatically. So when I see 3.8, I actually see 3.80. Okay? Good. So now let's get into the heavier algebra. And you guys are doing well. And if you still don't get it, there's nothing wrong with you, because this is extremely hard. Believe it or not, if you were having trouble understanding the numbers version, you actually might find this a little bit easier. So first you have to ask yourself, is this distributive property? I see parentheses, I see an addition problem inside, and then there's a number next to the parentheses. This is distributive property. So we're going to draw arrows from the number to each item inside. And then we're going to multiply. 8 times x plus 8 times 9. Now simplify. What's 8 times x? How do we write that? I don't know. That's weird. Brianna?
Put 8 and then we put the x right next to it.
That was a fantastic explanation. Yeah, it's just 8x. And 8 times 9, you should be able to do mentally. What's 8 times 9, Yasmin? 72. And so the result of the distributive property is 8x plus 72. You are not allowed to add the 8x to the 72 and get 80x. You are not allowed to do that. That is incorrect. You're going to learn next time why that's incorrect. But just for today, understand that you can't do that. Comments or questions? All right, part B. Multiply. It's distributive property. So we've got -5 times x. Now there's a subtraction sign that I have to be careful I write down. And then I have a -5 times 6. So how do I write -5 times x? How am I supposed to write that? Aaron? -5x. Minus, and what's -5 times 6? -5 times 6. Got 1, 2, 3, 4, 5, 6, 7, 8. Taylor? -30. Now, if you can get this, you're doing pretty well. but there's actually a detail that comes up in pre-algebra and algebra. And that is that we do not write answers with an operation and then another sign next to it. When we write a final answer, we do not write this. Does anyone know how we write minus a negative number? What is that really supposed to be? Got 3 people who have an idea? 4 people. Alex, what do you think it's supposed to be? So you think just take the negative sign away? Okay, but I'm not allowed to just take something away without a reason. There's got to be a reason why I could do that. Ethan knows. Go ahead.
Because it looks funny, so that's why they made a way for it to change to a positive by using add a line, change the sign, or keep, change.
That's right. And I like what he said, which was, this looks a little weird. We don't write final answers like that. Again, I don't know who will be using algebra heavily in their careers when you're in your 20s, but if you are, and you wrote something like this, your boss wouldn't be too thrilled, because it looks a little confusing, and we need things as simple as possible. So we rewrite it as add a line, change the sign, or keep, change. No matter what, it comes out to negative 5x plus 30. And that is the correct way to write your answer. Okay? Part C. First, we have to determine whether or not this is distributive property. Give me a thumbs up if you think it is. Is this distributive property? Some people think yes, some people think no. Okay, well, most of you put your thumb up, and that's good, because it is. And Aaron had helped us with another example that looks similar to this a little while ago. This is distributive property. So we multiply the number outside times each term inside. So this is going to be a negative 4 times m plus negative 4 times 3. Now simplify. We already know negative 4 times m is negative 4m. We're getting used to that. Plus, what's negative 4 times 3? Who's remembering the rules now? I know Taylor is. Taylor? Negative 12. But again, we don't write a final answer like this. We do not write answers where we have an operation, a parentheses, and then another sign. But this one's a little bit different than the last one. So how do we write plus a negative? Does anyone know how we rewrite that? How do we write plus a negative number correctly? I'll write the first part, negative 4m. Well, it's okay if you don't know. Plus a negative is really subtraction. When you add a negative number, you're basically saying subtract the number. So negative 4m plus negative 12 really means negative 4m minus 12. So we don't write plus a negative, we change it to subtraction. Now, you're going to have a checkpoint in a minute. We're actually not going to do part D. And my big concern is whether or not you can do the distributive property. So if you get this answer or you get this answer, that means you're doing pretty well. But I do need you to start understanding how to get from here to here and how to get from here to here. It takes some time for it to sink in. All right? So, checkpoint number 2. We got 3 minutes. Go ahead and begin.
Well, you don't have to, but the problem is you got it wrong. So had you rewritten it, you
Second one is right. Okay, so let's see who's, bless you, let's see who's starting to catch on. And again, even though we're most of the way through the lesson, if you still don't understand it, it's okay. Start with Chris, Aaron, Brianna. Chris, what'd you get for part A?
Negative 8x minus 56.
Okay, what'd you get, Aaron?
8x.
Okay, so we have a slight disagreement. Brianna?
Negative 56 minus 8x.
Okay, so that's actually the same thing that Chris said, but you rewrote it the other way. So the answer is negative 8x minus 56, and Brianna actually is right as well. If you wrote this, that means you understood the distributive property, but you didn't understand that last detail that I talked about, in which you don't write plus a negative, you change that to subtraction. So let me be clear. If you got this, then you are starting to understand the distributive property. If you got this, which is what I was looking for, then you are really doing a very, very good job of understanding everything that I'm explaining. Okay? Part B was a little bit tougher. What did you get? We'll start with Amaya, Christian, and then Aaron.
Negative 12m plus 21.
Okay.
Negative 12. Wait, what up? No. I got 33M.
Okay.
Negative 12M plus 2.
Okay. So the correct answer is negative 12m plus 21. And if you got this, that means you are understanding the distributive property. But this is what I was looking for. Now, Christian, the reason you got 33m was because you did a step that you're not allowed to do, which is you then added this and this. And you're not allowed to. Okay? I didn't explain why you're not allowed to yet. But I'm just telling you for now, you're not allowed to do that. You cannot add, when there's a term that has a letter and another one that does not have a letter, you cannot add them together. Okay? Delia.
What happened to the negative 3?
It got distributed. Negative 3 times 4m, and we get negative 12m. Here's what you should have written. Negative 3 times 4m. The second arrow is the negative 3 times the 7, but there's a subtraction between them. So you should have written this. From there, you get to here, and from here, you get to here. So the negative 3 was used. Now, I like the way you asked the question. What happened to the negative 3? We used it while doing the distributive property. Okay? Now, how come it wasn't a negative 3m? Well, this 4 here gets multiplied by the negative 3. The 4 gets multiplied by the negative 3. Excuse me. Okay? That was a very good question you asked. Other comments, questions? Okay? So now we're going to apply it to a real-world scenario. And I actually have a couple of examples, but I'm going to actually change this up. I do not want to use my first one. So everyone write example 3, finding area, and we're going to actually use part B. So just sketch the picture. And I'm going to actually modify this a little bit as well. Let's see. This W is not going to be there. So the base is 2, and the height is W minus 7. And we are asked to find the area of the rectangle. Well, let me back up for a second. What if I had this rectangle? How would I find the area of that rectangle? The one I wrote in blue. Oh, we got a bunch of people who know. Go ahead, Delia. Multiply what? Oh, that was great the way you said it. You multiply the base, which is this, times the height, which is this. Base times height. Okay? So we're going to use that same formula. Area of a rectangle equals base times the height. But this time the base is something different and the height is something different than what we're used to. So we're going to fill in the information. Area equals base times the height. But this time the height is this expression. So you can't just write times W, and you can't just write times W minus 7 because then the 2 is being multiplied only times the W. You have to write it just like distributive property. This really means 2 times W minus 7. And now, to write it correctly, we actually use the distributive property. Distribute, distribute, and we get area equals 2 times W minus 2 times 7. Simplify anything that needs to be simplified and write your answer. The area is 2W minus 14. Okay? So it was all based on the formula for the area of a rectangle. So it had to start with this. Okay? Any comments or questions on how we did that? Okay. Let's see how you do on your own. Your classwork is in the textbook. You're going to do page 75, numbers 5 through 11. All right, pick up your colored pens and let's see how we're doing now. Number 5 and 6 were pretty challenging. Number 5 is 17.9 and number 6 is 28.36. That's the same thing. Yeah, if you have a 0 here or a 0 here, you can add as many zeros as you want on the end and that doesn't change the value. Very good question. Numbers 7, 8, 9, and 10. So I think for some of us these were easier than 5 and 6, even though 5 and 6 were supposed to be easier, but they're not. They're hard. So number 7 is 2x minus 12. Number 8 is negative 3y minus 33. Number 9 is 20k plus 45. And number 10 is negative 8n plus 28. Number 11 required quite a bit of thought, but it was really a very good illustration of what the distributive property really means. So the total area of the rooms is 20 plus L times 15, and that's how you write that out. If you then multiplied it out, you would get, what, 300 plus 15L. So if you wrote 300 plus 15L, I would take that as well. Part B was really what we were looking for in that sense, but what we were looking for in Part B is just if you do them separately. So what if we found the area of that room, then found the area of that room, and then added them together? So that was the difference between Part A and B. Was that obvious or was that easy? No, that was not easy in any way. And Part C. When you use the distributive property in Part A, when you distribute here and here, you end up with this expression. And so what we're illustrating is, one second please, so what you're illustrating is that multiplying the first one and multiplying the second one is the same thing as adding and then multiplying. It's two different perspectives on the same thing. Amai.
For part B, I put 15 times 20 plus 15 pounds.
Okay. Very nice. Yes, absolutely mark that correct. Christian?
For A, I put 300. And I just put the L.
But again, you can't do that. You have to multiply the distributive property. Says we multiply, multiply. So if you'd said 300 plus 15L, that's okay. But if you wrote 300L, that's not the same thing, unfortunately. All right, other comments, questions on any of these? Go ahead, Aaron. Number 6, very good. So let's take a look at number 6. What I did, and it was not obvious, but I separated the $7.09 or the 7.09 into 7 plus 0.09. So when you distribute, 4 times 7 is 28. I know that 4 times 9 is 36. But then there's 2 decimal places, 1, 2. So I know that that's going to be 0.36.
Oh.
And then you add them together, and you get 28.36. Okay, so we only subtract when we bumped this number up. If we took this number and bumped it up to 9, what we did was we made up, we took money that wasn't really there, or we took a number that wasn't really there. So yeah, for number 5, I might have done 9 minus 0.05 and done it that way. And then do 2 times 9 is 18. 2 times 5 is 10. I know that in my brain. And since there's 2 decimal places, I know that I have to take 10 and put 2 decimal places in it. And so that's why we subtract 0.1. So some of you are struggling with the mental math aspect of this, and I'll take a moment to go over that. You guys are very bright with math, but some of you don't realize how powerful your brain really is. So let me just talk about what I just did. 2 times 0.05. You guys think, this is what you think. I'm telling you what you think because I know you guys extremely well and you don't even realize it. You guys think there's a decimal, I can't do that. I have to use a calculator. That's what you think. And I don't blame you for thinking that because that's what you've been trained to do. But I'm here to tell you that your brain is much more powerful than a calculator. Not just a little bit, not just kind of. I'm telling you that it's much more powerful. So now watch how this works. Everyone in this room can do this. There's not a single person in the room that doesn't know 2 times 5 is 10. Okay? If you know that 2 times 5 is 10, then you can do 2 times 0.05. How many decimal places are there from here to here?
2.
There are 2 decimal places. So just put that piece of information in your brain. 2 decimal places. Now do 2 times 5. That's 10. Now put the 2 decimal places back. 1, 2. This works with any decimal that looks like this. So we can do, let me move this up a little bit. 3 times 0.04. Does anyone know what it is already? We got 5 people. India? It's 0.12. So how do we do that so fast? Well, you should immediately be saying, oh, well, 3 times 4 is 12. But then there's 2 decimal places. So basically what I did was I took the decimal and I put it over here for a moment. So I went 2 decimal places in that direction just for a minute. Then I did 3 times 4 and I got 12. And now I'm saying, okay, now put the decimal places back. 1, 2 in that direction. So all we're doing is moving the decimal back and then forth. Okay? This is a technique that you guys should be using for simple numbers. Now, if I ask you to multiply 18 times 16.9875, would I expect you to be able to do that mentally? No. That's what the calculator is for. But you should not be using a calculator for 3 times 0.04 or anything like that. Okay? So there was a number of people who were saying, I don't get it. Is it starting to become a little clearer? Okay. Other questions on how to do this? Aaron, did I answer your original question, which was number 6?
Yes, I didn't multiply 4 times 0.9.
Okay, good. All right, excellent. Draw a line across your paper. Your homework is in the textbook, page 76. You're going to do 12 through 40, the even questions only. You're doing 52 to 62, the even questions only. And let's see, today is 2.2. You will have a quiz next Monday. And that will be 2.1 to 2.3.